Hey everybody, welcome to Mr. Maz's Win Group. Um, this is going to be a little challenging for me because this is supposed to be somewhat of an interactive lesson, but we're going to give it our best shot here to do this through YouTube. You hopefully have a writing utensil and paper to write on. It doesn't have to be anything special. Even a piece of scratch paper would work. But just a quick little activity. So if you do not have something to write with and something to write on, please pause the video for just a little bit until everybody has that done. Okay. So, that being said, some of you may have done this already, but how this activity is going to work is I'm going to say a series of numbers, and you have to remember them and write them down. Rule number one is you cannot write the numbers down while I am saying them. You have to wait until I have finished saying the numbers, and then you write them down. All right, so we're going to start off pretty simple. We're going to start off with just 3 numbers and then progressively add a number each time to see how many you can get. All right, so once again, I'm going to say these 3 numbers. Wait until I'm finished saying the 3 numbers, and then you can go ahead and try to remember them and write them down. So here we go. First 3 numbers are 7, 19, 21. All right, so that should hopefully have been enough time for you to get that the numbers were 7, 19, and 21. Go ahead and raise your hands if you got those right. Just kidding, I can't see if you're raising your hand or not. Hopefully, though, everybody's hand went up in the air and everybody got those 3 numbers correct. All right, we're going to do this again. We're going to add another number. So we're going to have 4 numbers this time. All right, and do not write down the numbers until after I'm done saying the 4 numbers. Oh, sorry. Okay, 4 numbers are 12, 14, 28, 32. Okay, so those numbers 12, 14, 28, and 32. All right, we should hopefully still be at the point where most everybody, if not everybody, got all of these numbers correct. So let's go ahead and add a level of difficulty. Let's go to 5 numbers. And we'll see where your breaking point is here. All right, so the 5 numbers are 3, 11, 10, 17, 23. I don't know how much wait time to give. Hopefully you guys have it. So those numbers 3, 11, 10, 17, 23. I'm confident with this group that at least half of you got this right. Hopefully you're proving me wrong and everybody's like, half. Hopefully everybody has them all right. But we're starting to get to the point where it's getting to be a little bit more challenging, where you might be good remembering the first 3, but then you struggle with the last 1 or 2 numbers. All right, let's move on. Let's go to 6 numbers this time. This is, if we didn't start to lose you yet, this is where we lose a couple. So hopefully we can get 6 numbers here. All right, here we go. These 6 numbers are 9, 13, 37, 20, 15, 6. Okay, so here they are. 9, 13, 37, 20, 15, and 6. Hopefully some of you got those right. That's usually the one where you remember the first two, and then your brain kind of gets in the way of itself, and you kind of get overwhelmed trying to remember what the last numbers are, and then you forget what the middle numbers are, trying to think after you on the first and second numbers. But maybe some of you got 6 numbers. And the whole point of this activity is to talk a little bit how your brain works and kind of the purpose of what we are going to be doing in my win while you're here for 4 or 5 days. So what we're talking about is your working memory. And a lot of you kind of know with your brain kind of has a short-term memory and a long-term memory. And when you first learn things, they go in your short-term memory. And you can remember them for a short term of time. Obviously, that's why it's named that way. And if you practice and work with it, you can eventually convert it to your long-term memory, in which case it's pretty much in your brain for good at that point. And you just have to be able to recall it, like retrieve it from that long-term memory. And kind of a part of the short-term memory we refer to as your working memory. It's kind of where a lot of processing is going on, dealing with the task that you are faced with right in front of you. And hopefully what this kind of proves, all right, is your working memory has a capacity. All right, so what do we mean by capacity? Think of a water bottle. All right, you take a water bottle to the filling station, you hold it under, and eventually that water bottle is going to start overflowing because that water bottle has a capacity. It has a limit of what it can hold. And your working memory is the same way. There is a limit to the amount of stuff that can be inside of your working memory. All right, so your working memory could probably handle 3 numbers very easily. It could probably handle 4 numbers very easily. But when we get to 5 and 6 numbers, your working memory probably struggled a little bit to keep that information inside of it and have you spit it back out. All right, now these numbers you're probably going to forget in 20 minutes, which that's not the point. The point is we have to do our best to free up our working memory for things that we really need to focus on. In 8th grade, you are either in 8th grade math or you are in algebra, both of which have some pretty complex math concepts. And if you're not good with simple math concepts and you have to kind of waste your working memory on those simple concepts, you won't be able to focus on those more complex concepts, and math is just going to get more and more difficult for you. So what we are going to focus on is freeing up your working memory for the more complex concepts, and we are going to work on something I call automaticity. All right, automaticity is the word of the day. It's fun to say. Try it real quick. Automaticity. Go ahead. Isn't it fun to say? It's kind of like that movie Elf, like with Francisco. All right. So automaticity. If you notice in the word automaticity, we kind of got the word automatic, which most people recognize and know right away. Automatic means just like that. All right. So if you haven't figured it out, of course, I'm talking about our math fluency, the stuff that we'll work on in quick tables and ALEKS, multiplying and dividing simple facts. We need to make that automatic. All right. So we can't be using our working memory. So if we get, 9 times 7, we can't be thinking, 63. All right. We can't be doing that. We got to go 9 times 7 is 63 right away. It's got to be automatic. So we need to try to make sure that we can recall these facts from our long-term memory and bring them out right away, bypassing the working memory. We don't even have to use the working memory for it. All right, so we should be able to see 7, 9, 63 kind of as that fact family and spit that out automatically. All right, so that's what we're going to work on. And some of you have heard me say this in math class. I will repeat it again. Math is not like riding a bike. And what we mean by that is the term, it's like riding a bike. All right, that phrase came from the fact that riding a bicycle is kind of a skill that once you acquire, you don't really lose it. All right, so you might ride a bike as a kid, a lot, acquire that skill, figure it out, and then you don't ride a bike for like 5 or 10 years. And then you come back as an adult and you hop on a bike and you know how to do it. All right. And you haven't really practiced it. It's just a skill that you remember and kind of have for the rest of your life. Math is not like that. All right. Multiplication, if you learned in 3rd grade and 4th grade and you mastered it, if you don't practice it, you lose that ability. All right. And same thing with all math. I was in Calculus 3 in college. I aced that course. But if you gave me a Calculus 3 problem right now, I would have no clue how to do it. I haven't done calculus in almost 20 years. All right. So math is not like riding a bike. If you don't use it, you will lose it. All right. So that's what the focus of this is going to be. And when I mention when you have Alex and you have extra time because you already get your topic, work on your quick tables. We need to practice this stuff and get better to build our automaticity, to build our fluency so we don't have to waste our working memory. All right. So this is not doing quick tables and learning fluency. It's not about wasting your time. It's actually about freeing up your time, and it's about making your brain better. Okay. Now, how do we build automaticity? It's through practice. All right. We have to practice, practice, practice. And there are good ways to practice, and there are bad ways to practice. And whoever came up with the term practice makes perfect is wrong. All right. Because if you don't practice the right way, you build bad habits. So someone else came along and they say, oh, practice makes permanent, which is a better phrase because that's true. All right. If you do something over and over and over again, you are going to create habits. Sometimes those habits are good. Sometimes those habits are bad. So we're going to try to create good habits. And what we found is kind of what you do in elementary school. You look at fact families. You put numbers together. We already talked about 7, 9, and 63. We try to mention 7, 9, and 63 together as much as possible. And we get those 4 fact families, or the 4 math facts from that family. So if I'm looking at 7, 9, and 63, I know that 7 times 9 is 63. All right. And I get another multiplication problem from this. I'm going to give you just a second. All right. Go ahead and yell it out. What's the other multiplication fact that we can get from this? I think I heard it. 9 times 7 is 63. All right, because multiplication is commutative. But it's the same numbers. All right, 7, 9, and 63, 7, 9, and 63. We put them together. All right, so we can build that connection in our brains that these numbers come together and help produce that automaticity. That when we see 2 of these numbers, we know what the third one is automatically. All right, now, with multiplication, we've got the inverse of multiplication in division. All right, so we can also have 63 divided by 7 equals 9. Same fact family, all right, the same 3 numbers, just a different operation this time. All right, so I'm going to have you tell me what the next division problem is based on this fact family. Go ahead, just yell it out. I'm going to say good, hoping that you did this correctly. But hopefully you said 63 divided by 9 is 7. All right. So from every fact family, we can get 4 different math facts. We can get 2 multiplication and 2 division. And what we're going to do is practice these over and over and over again. We're going to say these numbers out loud. We are going to practice using these numbers over and over and over again. And we're only going to concentrate on a certain number of facts at a time. Kind of the magic number is 5. I'm going to give you 5 different fact families to work on at a time in order to build that automaticity. This is the 3rd win group that we've had so far. And all of the win groups up until this point have been showing drastic improvement. And hopefully you guys will see that as well. Now, that being said, a lot of you probably already have good automaticity with these things. So we're going to go kind of next level based on how you perform early on. We might build a little algebra into this automaticity if you guys can kind of pass the baseline test here. All right, so I'm going to stop this video and I'm going to start another one here, and I'm going to show you how we are going to practice these things. And it's going to sound a little weird. It's going to be a little silly, but it is a really, really good way to do this, and there will be proven results from it. Okay, so what I did was I kind of created a website that is going to help us practice this automaticity. And what you probably worked on when you were in elementary school learning multiplication facts and division facts were flashcards. So essentially what I did was I made digital flashcards. So you see 6 times 48 here. Let me play these a little bit. Oh, my toolbar got in the way. Let me get rid of that real quick. So building up automaticity, we try to get these problems automatically. All right, so I think I have it set up for maybe 2 or 3 seconds before the answer appears, and your goal is to basically beat the computer. Can you come up with this fact before the computer shows you the answer? And as I mentioned, there are going to be 5 different fact families, and every fact family has 4 different problems. Unless the facts are the same, there's only 2 different problems. But we're going to work on this. Now, what a lot of people might do is they might look at this and they say 48. And they look at this problem and they say 12. And then the next one is 28. But that's not how we are going to look at these. All right. The better habit to create when we're trying to practice these is to say the entire family together. Once again, what we're trying to do is we're trying to create that association in our brain that's going to group these fact families together. So we want 4, 7, and 28 in our brains linked together so we can just spit out any fact that we need to from that fact family. So instead of just saying 28 for this one, we would say 7 times 4 equals 28. And then we would say, for the next one, 9 times 9 equals 81. 48 divided by 6 equals 8. 28 divided by 7 equals 4. All right, so we're going to try to beat the clock that way. And literally what I want to happen is everybody to be saying these fact families out loud. If I was in the room, I would be walking around, putting my ear next to everybody, making sure that I could hear them saying this. All right. And other classes says, Mr. Maz, it sounds like we're in a cult. And we're not in a cult. Cults usually have you do bad things, but cults also try to brainwash you. I'm not trying to brainwash you. I'm trying to get your brain to work more efficiently, all right, for good things, for benefits. So don't think of it as a cult. Everything's fine here, all right? We're just trying to build up the way that your brain works and make it better to create that automaticity, to create that fluency, so you can use your working memories for the more complex things in math. So I'm going to start this again. I'm going to say a few, and then I want everybody to join in with me, and then I'm going to stop talking, but the whole class should continue saying these facts. Once again, try to say them kind of quickly. I'll get a cadence going so you can kind of see the speed so we can beat the computer with the answer. All right, so join in. 81 divided by 9 equals 9. 30 divided by 5 equals 6. 12 divided by 4 equals 3. 3 times 4 equals 12. 5 times 6 equals 30. 9 times 9 equals 81. Let's hear you. Keep going, a little louder. Don't be shy. So hopefully you noticed it was the same fact families over and over again. So the last activity that we're going to do is we're actually going to write down every single one of those fact families. So I'm going to give you the first fact of a fact family, and then I want you to give me the other one. So one of them was 6 times 8 equals 48. So what's the other multiplication problem? I'm confident that's what you said. And then from that, we can get a division problem. 48 divided by 6 equals 8. So I'm going to write it, and hopefully as I write it, you guys are going to say the other division problem. Go ahead. Hopefully you didn't mess up like I did. Another problem that we had was 5 times 6 equals 30. So if we have 5 times 6 equals 30 from that fact family, what's the other multiplication fact? And hopefully someone is saying that out loud, because like we said, the more we hear these numbers together, the more they're going to build that automaticity in our brains. So a division problem from this, 30 divided by 5 equals 6. Go ahead and say the other one, and I'll write it. Another fact family we had, 4 times 7 equals 28. So the other multiplication fact. And we can also get a division fact. So 28 divided by 4 equals 7. And the other division fact, don't be shy, yell it out loud. And it's important to say these out loud. Once again, we got to hear these numbers in our heads so we can associate them with each other. Another one was 3 times 4 equals 12. So the other multiplication fact from this family. And a division fact we can have, 12 divided by 3 equals 4. So the last division fact. And then there was one more fact. There's actually 2 facts from this fact family because the factors are the same. 9 times 9 equals 81. So the commutative property gets it the same, and the division fact is 81 divided by 9 equals 9. All right. So tomorrow I will have another video ready for you to go through and practice some things. I'm going to have some actual practice for you to do, and we're going to make sure that we can increase our scores. So I'm going to come in. Hopefully you remember the mad minutes, the things that you used to do where you have a list of facts. You would get 1 minute to fill that out and do as many as you possibly can. That's what we're going to start class off with. So we're going to get a baseline. We're going to see how many you can do. Then we're going to do some practice for those facts. And then we're going to do the test again at the end to make sure that you are increasing your automaticity. All right, so these are the important things that we have to work on. All right, in order to free up that working memory. Remember the whole purpose of this. Free up the working memory so the simple math tasks can be automatic, and the more complex math tasks, you will have your working memory available to work on them. So yeah, I'll see you guys tomorrow.